What's up guys, Shawnthebro here, and in today's episode of the Fighting Game tutorial series, we are going to be going over improving our camera, converting most of it from blueprints to code, part 5. So this should handle the rest of our functions and the rest of our logic to code. Then we have to actually have an episode on implementing it and using that camera instead of the old blueprint camera. But after this episode, we should have a fully functional camera in C++. As you can see here, everything should function normally. We're not going to change anything that's going to ruin our logic today. Now, before we hop into this episode, if you want to get caught up in the series and check out how we've done everything from our launchers, our hit effects, our round timers, all that good stuff, I'll link you to the entire playlist of the Fighting Games tutorial series right here in the top right corner. You can click that to go to the playlist, but if you don't want that and you just want to know how to make a code camera for a fighting game, then I'll link you to the first episode of the camera right here in the Fighting Game tutorial series, because we are building on top of that logic and you will want to follow that. That way you have a good starting point for following this episode as well. And by the end of this little mini series within the fighting game, you'll have a fully functional fighting game camera in code. Now with all that out of the way, we can go ahead and get started. This is a code and blueprint tutorial series, but since we're converting things from blueprint to code, all of our actual changes are going to be in the code today. First thing we need to do is go to our camera. So blueprints, function BPs, cameras, base camera BP. There are three things we haven't converted just yet to the code, and that is our set outer boundaries function and the freeze camera and resume camera events. We're going to be focusing on the set outer boundaries function to begin with, so let's go to that, and then we'll copy over the logic that you see from blueprints to code. So first things first, we are going to need our set outer boundaries function. Now when I come into the code here, you can see that in the previous episode we created this because I kind of sectioned these things out. So in our base camera.h class, we have this function called calculate outer boundaries that we made in the previous episode. If for whatever reason you didn't make it then, you can go ahead and make it now. It should be ufunction blueprint callable in case we ever want to call this from the blueprints or have a child class of our camera that is a camera BP. And it is void calculate outer boundaries because this function doesn't have any parameters and it doesn't return anything either. Then if we go to basecamera.cpp, we want to make sure we have our function ready here. So void a base camera, : calculate outer boundaries. Again, we did this in the previous episode, but if you didn't, you can go ahead and add this now. Once you have this, you're ready to start converting. So the first thing we do is use our game mode reference to get our active team 1 character, or the character that player 1 is controlling right now. We don't have a game mode reference in the code. I've just been getting it from this statement right here. And then we can grab Team 1 character from the base game mode. So I'm going to do the same thing here. I'll go ahead and type it out. If auto base game mode equals cast. And we're going to cast the regular game mode to our fighter template game mode, because that's the game mode that we want to find. Get world, get auth game mode. So this is going to get the game mode that's in use, and we're going to cast it to our game mode because our game mode is the type that has the active team 1 and active team 2 characters. So after this, we can go ahead and do our regular check to make sure that active team 1 character and active team 2 character are set properly. So if base game mode active team 1 character and base game mode active team 2 character. We're going to want both these to be valid because we are going to use both of them for our calculations for the outer boundaries. The outer boundaries are the absolute maximums that the characters can go, so regardless of their distance in relation to each other, they can't move outside of these boundaries. These are the stage boundaries. So if we go back into the blueprint, we're using active team 1 character in their starting location, or the location that they have when we call this function. We were breaking the vector to get the individual values, and then we were subtracting 1000 from the y-axis to determine where this outer boundary should actually be placed. This is an arbitrary value. I just chose this because this is how far from the first character I wanted to put the left outer boundary. You can make this larger or smaller based on your game, and we'll make it a variable in the code so it can be configured. So basically, get the actor location, take their Y position, subtract 1000 from it, and then we can use this to make another vector. There's a few other things we have to do in here, which we'll talk about in a second. So first, we go into our if statement here, and we use base game mode, active team 1 character, get actor location dot y minus 1000 .0f That is this whole section right here. This next part we're using to get the left maximum. Now the outer boundaries can move as well if we want them to. We want them to be the absolute stage maximums, but it could change based on the stage you're on, so some stages may be larger than others. So while we have a default 1000 in here, and that's where we're setting the outer edge by default, we also have a left maximum, which is just the maximum distance or maximum location where these outer edges or outer boundaries can go. Now, in my opinion, we don't really need this. You don't really need to move these because you could always just force the left outer edge and the right outer edge to a new location. So you don't actually have to keep track of it the way we're doing here. But since I'm just converting this from blueprints to code, I'll keep this method. So we'll do this in a second. The other part of this is using our newly calculated location. We can set the outer edge, specifically the left outer edge, to this location. So this value right here is our Y position on this location. So let's go ahead and wrap this in parentheses because we're going to make a new location out of it. Say F vector, and we're going to pass in base game mode, active team1 character, get actor location dot X. And we can go ahead and clean this up a little bit just to make it easier to see what we're doing. After the Y section, we're going to comma, go down one more line, base game mode, active team1 character, get actor location dot Z. And now we have a new location. Well, set actor location takes in an F vector. So if we want, we can go ahead and call set actor location, passing in this F vector. In Unreal, you can see that we are passing in the target, which we're going to do that in a second. The location, which we just did, and then sweep and teleport are false, but they default to this in the code. We're not setting the camera's location off of this, we're setting the left outer edge. So we're going to type left outer edge, and it's going to look like this. This is going to set the outer edge to the location that we decided. Now, if we want, we can also make the left max. So to do this, this is a float variable, left max, with a default value of 0. So float left max equals base game mode, active team1 character, get actor location dot Y minus 1000.0f minus 200.0f. Again, we'll convert these to variables, but ultimately we subtract 1200 from it to get our final location for our left max. We're not going to do anything with that here. We'll update this in a few minutes. A quick little update here. So this is actually minus negative 200, which really means plus 200, but that's how I wrote it in the series. So we're going to go ahead and make sure we update this. It's not minus 1000 minus 200, it's going to be minus 1000 plus 200. Now everything you see here is done. Next thing we want to do is go and grab the game mode reference and then get active team 2 character, and we're going to do the exact same thing, but this time we're going to be adding 1000 and then we're going to be subtracting 200 to determine the right max, and we're going to set the right outer edge to this new location. So it's pretty darn simple. We can go up here and type right max equals base game mode, active team 2 character, get actor location dot Y plus 1000.0f minus 200.0f. Let's say set left outer edge outer boundaries. Then we're going to make right outer edge set actor location. We're going to make a new F vector and pass in base game mode, active team 2 character, get actor location dot X, base game mode, active team 2 character, get actor location dot Y plus 1000.0f, base game mode, active team 2 character, get actor location dot z. And now we've set the right outer edge to be at that position as well. So we've done everything we need to convert set outer boundaries to code, but now I want to go one step further and actually clean this up since it is in the code now. So instead of using these hard-coded numbers of 1000 and 200 for each of these things, I want to make new variables for this and switch them out. So if I go to basecamera.h, I can scroll down to my floats. The maximum position for the outer boundaries. And we'll say the maximum right position for the outer boundaries. We're going to make them the same U property as all the others in here, so edit anywhere, blueprint read right. And for our variable names, we're going to have float left max, float right max. And now we don't have to make these here, we're just going to set them here. This is following the blueprint because in the blueprint they are variables to the class, not variables in the function. Additionally, because of this, we will set them in the constructor. Left max equals 0.0f, right max equals 0.0f. Back in basecamera.h, I want to also make those variables for those modifiers that we added. The outer boundary maximum modifier, and we'll say offset. We're going to use the same U property here. We're going to say float outer offset. Back in the CPP file, let's go ahead and set outer offset to be 200. And let's actually make one for that 1000 as well. We'll call this the outer boundary maximum default. Same U property, float outer default. And we can call this outer default equals 1000. And now we want to go to our calculate outer boundaries and update these. So where we're setting left max here, instead of minus 1000, it's going to be minus outer default. And instead of plus 200, it's going to be plus outer offset. And then instead of plus 1000, it's going to be plus outer default minus outer offset. And when we're setting the actor locations for the left outer edge and the right outer edge, we can subtract outer default instead of 1000, and we can add outer default instead of 1000. And now we have successfully copied it over and improved the set outer boundaries function from blueprint to code. Thank you so much for watching this episode. If it helped you convert your blueprint camera to your code camera, then please subscribe. It does a lot for the channel. If you want to support the channel or myself further, you can check out the Patreon, YouTube membership, or Discord subscriptions, which I'll link right here in iCards in the top right corner, but also I'll show you the benefits on the screen. It really helps a lot, so thank you so much. If you ran into any problems while following this tutorial or any of my tutorials, feel free to join the Discord community. There's a link in the description, and I would be happy to help you. Thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.